Hey, Chem20, my daughter is still sick, so I'm not going to be there tomorrow, so I figured I'd make you a quick video. So our double tomorrow wasn't a total write-off. So what we're looking at is gas stoichiometry, very similar to mass or gravimetric stoichiometry, except for this time, what we're going to be doing is predicting or analyzing the quantity of a gas involved in a chemical reaction, while before we were looking at the quantities of masses or precipitates being formed. So we will be using, because we're dealing with gases, we'll be using the ideal gas law. Remember, that's PV equals nRT. PV equals nRT. In order to use the ideal gas law, pressure has to be, ooh, that's brutal, in kilopascals. Volume has to be in liters. N is moles. Remember, R is a constant of 8.314. And T is the temperature in kelvins. Also, we can always be using N equals M over M in these stoichiometric calculations because we can move, again, back and forth between these two formulas. These gas stoichiometry questions could ask us a variety of things: pressure, volume, moles, temperature, or mass. Generally, they're asking us something with mass or something with volume of the gas involved, but we can kind of go look at the questions and see what they look like. So if 300 grams of propane burns in a gas barbecue, what volume of oxygen is measured at SATP is required for the reaction? So if we remember from like the very first unit we did, propane is C3, 3 carbons, and there'd be a single bond attached to each of those carbons, making it C3H8. It's burning, so that's a combustion reaction, which means that the propane would be reacting with oxygen to produce carbon dioxide and water. First step I need to do in the stoichiometry here is to make sure I have a balanced equation. So to balance this, 3 carbons, 1 carbon, so I'll put a 3 out front of there. That changes my number of oxygens, but we'll deal with oxygen last. So then I go to hydrogen, there's 8 hydrogens, 2 hydrogens, so I'll put a 4 out front of here. Then that means I have a total of 4, and then 3 times 2 is 6. I have a total of 10 oxygens on this side and 2 on this side. So I put a 5 out front. That total reaction is balanced. Then I'll write what I know underneath each compound or each substance. So I know that I'm burning 300 grams of propane, and I'm trying to figure out what volume of oxygen would be required at SATP for this reaction to happen. Now, because they give me SATP, I know that's information about the gas, or I guess just information about what the conditions that this question are happening in. So I can take some information from here, which is that pressure is 100 kilopascals, temperature is 25 degrees Celsius, which we would convert to Kelvin, and R is that constant of 8.314. The second step in stoichiometry then is to try to find moles. So if I'm looking at these equations here, well, I have mass and I have PV, T, and R. I could use PV equals nRT, but I don't have enough information. I technically would have 2 unknowns here, but I could use N equals M over M to figure out the number of moles of propane that reacted. So I would use that formula. I know the mass. I can really easily figure out the molar mass, which is 44.11, 3 carbons and 8 hydrogens. To figure out the moles, divide those numbers, and I get 6.08 moles. Then I need to take this for my third step in stoichiometry, which is to take the moles and times by where you're going to, divide by where you're coming from to figure out the number of moles of oxygen that would be reacting here. So I would take this 6.81 times by where I'm going to, so times it by 5, divide by where I'm coming from, which is 1. So that's what I would do to get to the moles here, which is 34 moles. then I would be able to take all of this information and put it into PV equals nRT. So the pressure we know is 100 kilopascals, moles is 334, R is 8.314, and the temperature was 25 degrees Celsius, which we always have to convert to Kelvin. So I can put that all in the formula there. Now all I need to do is solve for volume, and to get that by itself I would just divide by 100 on either side. I guess you can see why I got these to fly in rather than me type it out. So divide by 100 on either side, that gets volume by itself, and so I end up with 842.9. And continuing with those decimals here, I have 3 sig digs based off the question, so the final answer with proper sig digs would be 843 liters. So in order to burn 300 grams of propane, it would require 843 liters of oxygen. Whew, now if that doesn't get you jacked up, I don't know what does. So let's look at one more, get you real stoked for the day. Okay, example 2, hydrogen gas is produced. Sorry, just grab this. So hydrogen gas is produced when sodium metal is added to water. What mass of sodium is necessary to produce 22 liters of hydrogen gas at SATP? So that means that I'm taking sodium metal, solid, and adding it to water, H2O liquid. I'm producing hydrogen gas as well as, so if I actually look at water as if it is HOH, you can see that this is actually a single replacement. Hydrogen gas is coming off by itself, and this OH attaches onto the sodium to give you sodium hydroxide. HOH. So I'd be producing hydrogen gas and aqueous sodium hydroxide. And so the first step in stoichiometry is to make sure that you have a balanced equation. So if I look at this, I have 2 hydrogens, or 1 sodium, so that's okay for now. 2 hydrogens, 3 hydrogens, so this is odd. So if I put a coefficient of a 2 out front, that gives me at least an even number of hydrogens. So now this side is at 4, and this side is at 2, so I can also put a 2 out front of both of these. So now I would have 2 sodiums, 4 hydrogens, 4 hydrogens, and 2 oxygens. So that is my balanced equation. Second step, or I guess still part of the first step, sorry, is to write what we know underneath each thing. We know we're looking for the mass of sodium. Generally, if they give me mass, I also immediately want to find molar mass, and I believe off the top of my head the molar mass of sodium is 22.99. We also know that we're producing 22 liters of hydrogen at SATP, so I can write all that information down. I know R is 8.314. The volume we're producing is 22 liters. Pressure is in kilopascals at 100 at SATP, as well as the temperature is 25 degrees Celsius, which is 298.15 Kelvin. We have to have it in Kelvin. Now, second step in stoichiometry is to figure out moles. If I look at this, I have an unknown. Here, I have enough information I could figure out moles. So I will use PV equals nRT to find moles, and so take all of this information and substitute it into the equation here. So pressure is 100 kilopascals, volume is in 22, which is in liters. I'm trying to solve to get N by itself. R is 8.314, and the temperature is 298.15 Kelvin. I would have to divide this, by 8.314 and 298.15, multiplying those together. Woo! And I would do the same thing on this side, divide that by this number to get moles by itself. And the number of moles then that were produced is 0.8875, and we have to keep that trailing decimal. The third step in all stoichiometry is to do that molar ratio, so times by where you're going to, divide by where you're coming from. So in this case, I would be timesing by where I'm going to. I'm going to try and figure out the mass of sodium, and I'm coming from figuring out the moles that were in hydrogen. So I'd times by 2, divide by 1, looking at the coefficients. That makes the moles of sodium that would have reacted 1.775. Again, I just keep that trailing decimal in on my calculator. And now I have enough information to jump into m over m. So I put the information into there. So 1.775 moles is equivalent to the mass, which is what I'm looking for, over 22.99 grams per mole. And then all I would have to do here is cross multiply to figure out the mass, which is 40.808, and then that decimal continues on. Based off of the question, there are 3 significant digits, so this doesn't round, so I'd have 40.8 grams as my final answer. Okay, so one more last example before you go look at the information there in the homework book. I would get you to pause the video right now, read this out for yourself, and try and answer it on your own. I will just kind of slowly go through it point by point here if you kind of need a few steps. But again, please try this on your own and then reflect back on the video when you get stuck, or if you just want to check if your answer is right. Okay, so the question says ammonia is widely used as a fertilizer. It is produced from the reaction of nitrogen and hydrogen. So that kind of gives me the reaction that nitrogen, which is diatomic, is a gas, reacts with hydrogen, also diatomic, which is a gas, produces ammonia fertilizer. Balance that out. 2 ammonias, 2 ammonias, 6 hydrogen, that's balanced. And then I would write what I know underneath every single substance. So I'm looking for the volume of ammonia that would be produced. I know the pressure is at 450 kilopascals, the temperature is at 80 degrees Celsius, which I convert to Kelvin by adding to 273.15, and R is 8.314. Man, I didn't want to write the unit, so I was lazy. We also know that we are reacting completely with 7.5 kilograms of hydrogen, so I put that in for the mass. That should be over here, sorry. But my molar mass is right. So 7.5 kilograms, we need to convert that to grams by timesing by 1,000. So it would be 7,500 grams. The molar mass of of hydrogen is 2.02. And that gives me enough information then to figure out the moles of hydrogen. So the moles of hydrogen would be, if I take that 75,000 and divide it by 2.02, I get 3,721 moles. Then I need to use the molar ratio, times by where I'm going to, divide by where I'm coming from. So times by 2, that's where I'm going to, divide by where I'm coming from for the coefficient of hydrogen. That gives me the moles of ammonia being produced as 2,475. Then I have enough information here to go into PV equals nRT. So put that information in for the formula. I need to solve for volume, so divide by 450 on either side, and your answer should come to be 1.6 times 10 to the 4 liters or 16 kiloliters. Either one of those would be an acceptable answer. So you're going to do homework 4 in your, this is definitely not the right unit, but in your homework booklet. If you have any questions for those, we will go over that tomorrow. If you're not sure of your answers or any of the questions, let me know. Hopefully you guys should be able to manage this. It's really no different from gravimetric stoichiometry, except for now we have that PV equals nRT formula, which hopefully you're a bit familiar with because we've already did it in the gas unit. Okay, thanks. You'll have a lab to look at next block that the sub should give to you. Hope you guys have a good day.